Okay, so we live in Facebook, and whenever you're ready to start, we can start.
Okay. Yeah, I think I'm ready. Okay. Okay, so yeah, this is the second session in a series we're doing about SQL or SQL and databases. So learning about yeah, like introductory sort of SQL and how to make queries and how to set up your own database and what kind of tools are out there for doing that, and then how to actually get data out of the database and you know, analyze it and yeah, just basically learning about data organization. So this would be like kind of an intro to that. And like I said, yeah, this is the second session. The first session, I'll share a website here in a second that kind of will act as like a repository for all of the previous sessions and sessions going forward. So you can always look back at that if you missed a session and you want to catch up. But you know, generally speaking, I try to keep it like pretty like concepts are pretty unique. So I mean, certain things will build, but I'll try my best to keep things pretty unique across sessions. So that way, you know, hopefully you can at least take something away and learn something new each time. So yeah, my name's Page Swanson. I'm a full stack web developer for a financial software company. And I've been doing this residency at the library for about a year now. I think almost yeah, coming up on nearly a year. So yeah, that's really exciting. Really glad to work with them. And I don't know if Celeste, do you want to say anything in particular about?
So I'm Celeste, and I work at the library, at the New Haven Free Public Library, and I'm really happy to have you here. And if you have any questions, please just put it in the chat, or just feel free to unmute yourself and just ask the question. And hopefully this is helpful for you and for maybe projects that you're working on. And if you want to mention your work office hours on Mondays page, that would be great as well.
Yeah, great. Yeah, I will go ahead and share my screen. I have that pulled up right now, actually. Oh, can you enable screen sharing? But yeah, I have that pulled up. So
okay,
great. Perfect. Thank you. Okay, so I'm going to share my screen. Okay, close that. So what I'm sharing right now, well, first I'll share the office hours link. So it's at calendly.com/coder-nhfpl. And if you just click this here, you'll be able to see the schedule upcoming, like for each month. So like on the 31st, I have 4 blocks available. So all you do is you just click a block and then you sign up for which block you want to do. It's 30 minutes blocks. You should be able to sign up for multiple blocks if you want to. There's nothing wrong with doing that. So yeah, feel free to. It's like a first come, first serve sort of thing. Okay, and so what I'm showing now, this is kind of going to be the home page for the course. So like I said, this is a series introducing SQL and databases for the New Haven Free Public Library. I've got a couple of different files and folders here. This is the sample database we're going to be working with today that I talked a little bit about last session. But if you go into this folder, so if you wanted to follow along, you can jump into this folder here. This is where I'm going to be working from. And then the sessions are organized by like number in the series. So this was session 1. If you want to look back at the notes from the last session, these are all available to everyone. So you know, feel free to take a look at these notes, but we'll be working from this second set of notes today and kind of moving forward with the series. So yeah, let's go ahead and get started. Okay, so I always like to start every series kind of like installation off with a few helpful resources. So usually I'll just share one, but this time I had a couple that I wanted to share in particular. Some of these are like references that I used in kind of like building some of the material for the sessions here, and some of them I think are just pretty useful. So the first one is this database system concepts text. and in particular, the chapter on Introduction to SQL. So this is a really comprehensive introduction to SQL. As you can see, it's like 60 pages long. So there's tons of material in here. It's very useful. I definitely referenced some of it to make sure that I was presenting some of the concepts in a helpful way. So this is really cool, and it goes very deep. So I would encourage looking into some of this stuff if you get more curious. This particular link here, the Sqlite select documentation. So I think I mentioned last class, but again, if you're new, that's okay. You'll learn that we're using a particular implementation of SQL, an implementation of the SQL standard called Sqlite. So Sqlite is like a very lightweight, small, hence the little feather logo. It's a very small implementation of SQL, but has basically everything you'd need, especially for doing small database work. And so this particular documentation is going to cover most of what we're going to talk about today. In fact, it's covering all of what we're going to talk about today and then some. So I'm not going to touch on all of this stuff because there is a lot to go through here. But I'm going to try to discuss a lot of these things in particular. And I think it's just a really interesting piece of documentation. It kind of explains to you how the select processing is done. So like when you do a select query, like we're going to see shortly, like how it's built and what it's composed of. It's definitely very detailed, but I still think it's pretty cool. And then lastly, we're not going to do this today, but I'd encourage you to go try it out. It doesn't really use a lot of SQL. In fact, you can use SQL with this, but it's not really for that. It's more for plotting out your database organization. So someone who is like you have a lot of data and you want to create a database for it, this would be really useful. But the code over here to the left isn't exactly SQL code. What it's doing is basically, it's just a bunch of table definitions. And so the reason I want to show this is because this is a really useful way to think about database tables, wherein each of these big blocks is a table. Okay, and then each of these little rows is a column in that table. And then it shows the type of data that's in that table. This is a pretty complex, like random, this is just a random set of tables that was generated. These are pretty complex. We won't be dealing with stuff that's this complex right away, though we'll get to it, I think, a little bit later on. But yeah, this is a pretty somewhat complex table arrangement, which we might look at later. But it's still really useful to just kind of like take a look at the different kind of things that you can achieve with some of these table kind of like table arrangements and things like that. So I think this diagramming tool is pretty useful. And actually, I think you can generate SQL with it. So once you have your tables laid out, you could generate some SQL to actually create those tables in your SQL implementation of choice. So like Sqlite, for example. But I don't know how much we'll spend doing that. Okay, so yeah, just some reminders as far as like last session goes. This is the tool that I'm going to be using to actually run SQL queries, SQL statements. It's called Sqlite Browser. I introduced it in the last session, but if you're new, go ahead and check this out. If you scroll down here, you can like install. You can try to install the Sqlite Browser if you haven't already, in order to like follow along, but don't worry about following along, step by step necessarily. I try to be helpful in the notes and give you information to like learn along. So it may be helpful to just watch, but it's totally up to you. Okay, so I also mentioned getting a text editor. So text editor is going to be useful for doing things like editing, like SQL databases if you want to be able to do that, or if you want to be able to do like write out longer SQL statements in an editor so you can see the syntax highlighting and stuff like that. is just generally going to be pretty useful to have. And I mentioned a couple in the last session. You can take a look at the notes to see some of the different offerings. And then I already mentioned I have my office hours. And then this is my email. So if you want to email me with any questions, you can do that. Okay, so what we're going to cover today is going to be an introduction to SQL syntax in particular, and in particular for select statements. So select statements, what is a select statement? This formatting got all messed up, very unfortunate, but still the link worked. So what is a select statement? We can go here to this kind of Wikipedia link, and we can see kind of like what it says at the very top, which I think is a pretty good definition. So the SQL select statement returns a result set of records from one or more tables. I think that pretty much sums it up. I mean, it's not too complicated. What you're trying to do with the select statement is part of a specific subset of tasks that are implemented with SQL. So if SQL is what's called a structured query language, that structured query language, it has requirements for like what it should be able to do. And so this is actually defined here. I got this from the Wikipedia page as well. So the scope of SQL includes data query, data manipulation, data definition, and data access control. Okay, so select statements are a data query. So data queries would say like things like, is this data in my database? Or is this data and this data, like, are they related? How many records are a part of this particular table? Things like this. Data manipulation, which we'll get to next session, that's going to be things like inserts, updates, and deletes. So you're going to be changing the data that's inside of the database so that you can change the way that it's viewed or used. And then data definition is even higher level stuff that we'll get to a little bit later on, kind of like what I was showing with that diagram. So that's going to be things like, I want to add a table. I want the table to have these columns. I want the columns to be of this data type. You know, like I want this column to have numbers. I want this column to have strings, like characters in it, like words, you know, things like this. And then there's data access control. We're not really going to touch much on that at all. But that is going to be stuff like, you know, oh, these people can access this data in the database. Like you'd set up like permissions effectively. So like, you know, like you have different users on your computer. Well, you could set it up. You could set up your database such that only certain users can access certain pieces of data in the database. So this is very useful for larger systems of data. Okay, so getting back to the narrow point on select statements are a data query. So we're asking a question about data that's in the database, and it's going to look something like this. So this is a basic select statement, right? You can, oh, cool. You can actually just copy it by clicking that. So that's nice. So a select statement is going to tell us basically, you know, what data is in the object that we're asking about. In particular, the object we're asking about is Facebook info. You don't have any context for this because I haven't shown you the sample database that I've loaded yet, but I'll show you that in a second here. But we're going to ask, you know, basically give me all of the records inside of Facebook info. That's what the star means, which we'll learn about in a little more detail a bit later. So this is used to seek data, so search for it, and then deliver it to you. So like deliver it to your screen. That's often sometimes called a view. Okay, so first of all, we'd like to run this query, I imagine, against a database to try it out. So what I've done is I've set up a sample database, which I've loaded. Here's what I'll do. I'll open this in another tab. Put it over here. Okay, so this is the sample database. It's loaded and ready to go. What I'm going to do is I'll go back down here, and I'm going to load it into my Sqlite browser, which I mentioned right here. So this is the tool that I wanted you to go and check out. And then there's a tutorial on getting that set up in the previous session. There's a link there, so definitely check that out if you want to kind of like get some other sample data. I just used the sample data from that tutorial, but if you wanted to edit the data, it kind of gives you instruction on how you might go about doing that. Okay, so I'm just going to go to documents here. And okay, so what I'm going to do is I'm going to minimize this, and I'm going to actually run the application. So I installed the application. I'm running it right now. It's going to open up, and it's not going to have any data in it. Like there's no data here. So what I have to do is I have to open an existing database, which is going to be that file that I showed you. I have the file already downloaded on my computer. You would just kind of do the same. You could just download the file. So I have it right here. I'm going to click open. Okay, when I open it, it's going to tell me basically what's called the schema of the database in a kind of a brief overview. We'll get into that in a little more detail later. We'll also learn like what this statement is doing, trying to understand it. But in the meantime, we just need to know that there's a table called Facebook info in here, and it has these columns. Again, this comes from that link from lesson 1. So they provide this example data called Facebook info. So I just loaded that into a database. And then what we're going to do is we're actually going to go over to this tab, execute SQL, right here. And then I'm going to click that. And what I can do now is I can begin to add queries right here or SQL statements. So for example, I'm going to add this one. I'm going to copy it, and I'm going to paste it in here. And I'm going to click play, this play button. It just means execute. So you can also press F5, I think. So I'll press F5 on my computer. So I'll press F5. We can also press play. It does the same thing. You can see it refreshing. So it's doing two things here, mainly when we do this select statement. And I'll go ahead and cover this now because it'll apply later on when we do different kinds of queries. And I don't really talk about it too much in the notes, but it's not like you would be lost if you didn't know this stuff, but it's kind of useful, I think, to understand. So there's two sort of sets of results that I'm getting back here with the execution of this statement. The first set that I'm getting is the actual data. So this is the data that I was seeking, and then this is the view. This is the view of the data, like the results that I got from the query. So I said basically here, select all attributes. So select all attributes, like don't exclude any of them. So this is every attribute or column on, like in the table. So the table is called Facebook info. So basically I said, get me everything from Facebook info. And that's it, just do that. So there are the results right here for every single attribute, row by row. The way these records work is, basically inside of a table, you have records. They're often called records or rows. Each record has attributes, and those attributes are, basically completed or fulfilled for each unique record. So here we have like ad ID, FB ID, impressions, unique. So these are like, I think this is supposed to be like fake ad data, So what we're seeing here is basically a row. You can click like that for each entry in the table, and then columns for each attribute in that table. So you can, for the most part, think of like SQL data as like kind of like a spreadsheet, but I think as someone mentioned last class, which I think is a pretty good way to looking at it, really what SQL is, it's like a multi-dimensional spreadsheet. So there's other tables that we can interact with, that we can like pull in. We can build relationships between our different like tables. So people will call these, like I said, records or rows, and these are like attributes or columns. I tend to use rows and columns. So I might say rows and columns. I think in the notes I put attributes. I can make that more consistent. So maybe I'll just say attributes. So these are attributes and these are records, which I think is clear enough. Okay. So now that we know what our application looks like, this is what it looks like when we run a query. These are the results we get. What is the second part? Well, the second part here is basically just giving us statistics on the execution that we just performed, and it tells us a handful of things. It tells us, first of all, that there are like no problems with the query. If I do something like this, let's say I remove an O, you notice too that the syntax highlighting or like the color changed. That's because it doesn't recognize the identifier that we're using. And actually, it'll try to complete the identifier for us, yeah, because it says, oh, I think I know what you're trying to look for. And then you can click that, but I'm going to make it, use an identifier that's bad. And so you'll see here what will happen. I used a bad identifier, and what happened is I get no results because there is no table called Facebook info. And the execution notes that it finished with errors. So if I set this back, and it even tells me actually what was wrong. So it just says like there is no table called Facebook info. So that was the problem. So let's run it again. Everything's corrected. We get the same results we did before. And if you notice here, the result is instead that there were 65 rows returned. It'll tell you how fast it did it. And then it tells you basically like which SQL statement produced that result. Okay, so hopefully that's pretty clear. If you have any questions, feel free to chat. Feel free to post in the chat. I can always answer questions midway or just speak up. I'm happy to. Like don't worry about interrupting or anything. If you have a question. Okay. So we know the general idea behind a select. We know like what a select statement does. Let's kind of dig into some of the syntax behind the statement itself. So when I talk about a statement like this, what composes the statement? Like what is the statement made up of? So the structure or the syntax of a statement is basically describing like sort of like each component of the statement as a whole. So we can just identify with our eyes, like, or if you're hearing if you're hearing a sentence or something like that, like you can think about, okay, there's different parts of that sentence that I'm breaking down, and I can get meaning from each of those individual parts. So that's what we mean kind of like by syntax. It's like how a statement like this is structured. And let me just check the chat really quick. Oh, you joined late. Will the recording be put? Yes, the recording will be posted. Yes, absolutely. And Celeste, maybe you can chat about some details on that. But I think Celeste.
Yes, of course. I will answer.
Oh, great. Okay.
Yeah.
Awesome. All right. Thank you. Cool. Okay. Yeah. So now that we know like what a syntax is, specific SQL statements, like different types of SQL statements, they're going to adhere to a different type of syntax or like a specific syntax. So not every SQL statement is going to look like this, right? Like there are different SQL statements as you can imagine, and they're going to look different ways. They're going to adhere to a different type of syntax for that. So select statements in particular have what are called like multiple clauses. Okay, so a clause is going to be basically everything in SQL, at least. It's going to be everything following a keyword before the subsequent keyword. Keywords are these words that you see in bold, and SQL is actually case insensitive. So because it's case insensitive, that means that basically, oh great. That means that I could type like lowercase select. It'll still work. It doesn't matter whether it's lowercase or you could do like that, which looks ridiculous, but you could do it and it'll work just fine. This looks like it's like kind of taunting you, I guess. Like that SpongeBob meme. But yeah, like you probably wouldn't do this because it's not very legible. So I like to do capital letters. Sometimes I'll do lowercase letters just because most editors that I'm using, like this one, tend to highlight that keyword. So this works fine for me. I don't really mind whether you do either one. I wonder if I can zoom in. Oh, I can. Oh, how much? Oh, there we go. That's much better. Okay. Hopefully everyone can see that. All right. So yeah, this would be like a clause right here. So this is like one clause. Okay. This is the second clause. In fact, I'm not even gonna like, let's we won't rely on myself to do this. Let's jump to this Wikipedia article, which kind of breaks down the SQL syntax in a really helpful way. Okay, so I really like this diagram that they make. This is a really, really good diagram explaining. This is, in fact, an update statement. It's not a select statement. I don't know if they have some select statements. I do have a link to select, I think. Yeah. I wonder if they'll have like a syntax breakdown in here. That says good. They don't. It's okay. We can use this other statement. It's not a big deal. You just don't know exactly what this statement is yet. But basically, there's these different clauses you can see delimited by keywords. So each keyword prefixes a clause in that full statement. So the whole thing together is a statement. And then each of these are clauses in that statement. And then within those clauses, you might have expressions, which we'll get into in a second here, to kind of to function for different clauses in different ways. So hopefully that makes sense. So it's like statement is made up of clauses. Clauses can be made up of expressions, and specific types of clauses use a predicate, which gives a logical result, which we'll talk about in a second here. Okay. So getting back to this. Let's get my database back here. Okay, so the select clause, this first one here, includes the select keyword to begin with, and it includes the selected attributes from like the records that you're trying to read. So in this case, I've done a star. Select star means it indicates that all attributes be selected. So when I do my query, when I run my select query, I want to see every attribute for all of the records I've selected. So if we want to limit the number of attributes included, all we would do is add a little list of attributes here. So what I can say is AD/ID, so that's one attribute. And you can see it's trying to give me suggestions. And sometimes people will actually break the clauses on lines. I kind of like doing that. So I do that sometimes if I want to be really clear. We can select FB/ID. So that's another attribute there. And it auto-completes for me. And we'll select like engagement rate. It's a pretty interesting property. Okay, so we've selected those. And then what I'll do is run it again. And you'll see here now the result set, the view of results is now limited. So there's only 3 attributes included for all of the records. Notice here that the number of rows returned, see, yeah, they actually call it rows. They don't use the word records. The number of rows returned is like the same as before. And to prove that, I'll just go here and I'll copy this again. And I'll just run this below. Most database tools, by the way, you can just basically highlight a statement and only run that statement. Notice like it just tells me which line executed. So I'll do that a lot if I'm trying to compare the results for different statements very quickly, just to eyeball like, okay, this one looks different from this one, etc. But yeah, so we can see in comparison, right? This is returning 65 rows, okay, and it's returning all attributes, whereas this one's returning a limited number of attributes, but it's still the same number of rows. We haven't changed the data, like the amount of data that we're returning in terms of like entries. We're just changing what about each entry we're seeing. Okay, so that's the select clause. The next clause is the from clause. Okay, so the from clause basically tells us from where we are getting the results that we're looking at right now. Okay, so the result set is basically coming from Facebook info. Facebook info is a table. And it's using an identifier, a unique identifier, to specify which table we want to pull that information from. Like I said before, if we spell this wrong or anything like that, the query won't work. It will be unsuccessful. So finish with errors. So we need to get that identifier correct in that from clause. So this is the from clause, the complete from clause there. The idea here is that we're relating to the table Facebook info. We're using this statement to relate to a table to get records from it. Often you'll hear the term like relational databases. This is a relationship. A table is like a relationship. It's a data relationship. Okay, so like the records that we're getting from this query belong to this table, for example. That's like one relationship. And more clauses can be used to configure the presentation results. So there are other clauses that are out there that are part of like what's typically called a select statement that you can use, and we're going to talk about a few of them in a second here. So that kind of covers, just very basic, like, so hopefully already you can do some, I would say you can do some pretty powerful stuff. I mean, this is really cool. Like you can instantly get results from, you can take this and like with this DB browser system, it's really cool. You can you can click this here on your result select and you can copy that. So I'm just pressing like Control-C or Command-C on the Mac. I can copy that, and let me open a text editor here. So these are just the notes for the class. So if I paste this, you see this, I get every single result from the view that I just got by running my query. So this is really, really useful because as you can see, right, I could do like some SQL. I could use some SQL and then I could copy this into like a spreadsheet or something like that. So already this is, I think, pretty useful to be able to do. Okay, so let's move on to the where clause. So these are often called filters. So filtering data is really important in database operations because more often than not only do you probably not want to see all of the data inside of this table every time, you probably have particular questions about the data that would lead you to want to just find like some particular records. But also your data might be bigger than just this table. Like this table only has 65 rows. Your table may have something like, thousands of rows or maybe even millions of records or rows. So, I mean, you really at that point would not want to select all of the data from the table. So that's where filters come in. Filters are probably, it'd probably be pretty uncommon that you would actually see a select statement like this without a filter, because filters are just so, filters are so much a part of select statements. And most SQL statements, in fact, most different types of SQL statements. So let's try to figure out how we can play around with this particular filter and see if we can learn about some different types of filtering. So I'm going to copy this statement just like I did the previous one. I'm going to open this database portal here again. And I'm just going to remove this query because I don't need it any longer. And I'm going to paste this. And what I have now is a new statement with a filter on it or a where clause. So I'm now going to break the clauses onto each line. So whenever I do this going forward, I should have broken this onto a line in the notes. If I remember to do that, I will, and I'll make that update so it's clear. But this is the new clause that we're adding. So this is a where clause. So what I'm doing now is I'm asking the database, I'm basically saying, get me all attributes from the table Facebook info where the attribute unique clicks, the value for that attribute is less than 1,000. So I basically am saying, only get me records where this attribute value is less than the number 1,000. And specifically, simultaneously, I'm saying, don't get me any records where unique clicks, where the value for unique clicks is equal to or greater than 1,000. So that's really what I'm saying as well. I mean, both are true in this case. So I'm going to run this statement. You'll see I get a very limited number of records. That's because unique clicks here, I guess, tends to be above 1,000 with this data set in particular. So you can confirm quickly just by looking, right, that this in fact did come true for us. It turns out that in fact all of these records do have a value below 1000, and we can even filter this further, right, like to just confirm our understanding of the query. So I can say now 900, right? And so what we can expect is that this record will disappear, this first record. That shouldn't be present any longer because it would be then greater than 900. So I'll run this again, and in fact, like that record disappears. So the record's gone. And that's because we filtered it out, or we created a where clause that excludes that particular record. So let's break down the syntax again for this type of clause, or this part of the SQL select statement. So it starts with the where keyword, just like the other clauses. So it starts with a keyword. And I mean, maybe, unless I'm just totally forgetting something, every SQL clause, every clause in a statement will start with a keyword. I would be surprised to find a case where that's not true. But I can be pretty certain, I think, that that's the case. So that's a good generalization that you can make. And then basically what we're doing here is we're giving this expression. This is called an expression here. So it's a little bit different from this. This is an identifier. It's like a table identifier. It's saying, where do I get the data from? This is like an expression. This expression is going to be evaluated to determine which records should be pulled. This expression is a particular type of expression as well, which I'll get into it in a second here. Well, I'll get to it right now, actually. This expression is a predicate expression. A predicate expression, the term comes from predicate logic. Basically just means it's like a logical sentence or a logical statement that needs to be one of three things. It needs to be true, it needs to be false, or it needs to be unknowable. An unknowable in SQL in particular it has an important purpose. I created a link here, which kind of explains like how the unknown aspect works, but this is called null logic, or null, or like three-valued logic. So SQL has this concept of null. We don't really see this in our particular table, in our database. By the way, you can also select portions of a query and run them independently. So like this is still syntactically correct. There's nothing wrong with this SQL here, apart from the where clause. So we can just run it independently and get our original results. So 65 rows returned like we were getting before. None of this data here is null, like it's all populated. There's values for every attribute in every entry. But later on, what we might do is add some null data and mess with that and try to figure out what that means for our queries and how it changes the way we will query and get results and build filters. But they do have this kind of useful expression table here for when we build expressions or do comparisons for expressions. And it can kind of tell you whether or not something will be true or false. And when you're building these where clauses, really the way you need to read this is, for an individual record, is unique. If unique clicks is below 900, that returns true. So meaning like you would say, you would look at each individual record in the table. You can kind of think of it like this is what this tool is doing when it runs our SQL. It's saying, okay, I'm going to go to this table, Facebook info, and I'm going to evaluate this expression, this predicate. And I'm going to say, okay, let me go to the value for unique clicks. And I'll say here, is unique clicks less than 900? Or is it greater than or equal to 900? If it's greater than or equal to 900, then I will return a false. So this becomes false. Oh, sorry. I think this will actually just return nothing. Yeah, it returns nothing. If I say true, this will return everything. Or it'll close the Whoa, why did it do that? Just close the database. Uh-oh. I think I crashed it. It did not like that I said.
Oh no.
Oh no, yeah. It didn't
Well,
like
these
that I
things
said.
happen, so I mean, it's gonna happen. So
Oh
everybody
yeah,
can
yeah.
see it.
No, no problem. Yeah, we
Sometimes
can.
it's a trial and error.
Yeah. Trial and error, exactly. I've never had that happen. That's kind of funny. Okay, I'm not going to run that query again, but there should be nothing wrong with that query. It just means get every piece of data in the table. But it really did not like that I did that. I'm kind of tempted to try it again, just to see, because I don't expect there to be a problem with that. So I'm just loading the data again. And we're back to where we were. That's all you have to do each time you close it. I'm curious about this because like I don't think that should cause a problem. But we're going to find out. It's probably going to crash again. Oh, no, it didn't crash. Yeah, I don't know what happened. Maybe, does anyone know if I actually had this? Maybe I'm just lying. Maybe I had something different. It worked fine on your end. Okay, thanks, Cassidy. Yeah, I don't know. Maybe I had something different. Anyway, okay, glad it worked fine. Yeah, so it works well now. And that's because basically what Sql is saying is it's going to every record and evaluating this expression. And this is what indicates whether or not a record will appear. So if we just say where true, it just means basically it's going to go to that record and say, okay, like, what about this record qualifies for my expression such that I can return that record? And then it would just see true. So I'd say, oh, okay, well, I guess I'll just return this record because it's always true. If we say false, it's doing the same thing, except when it goes to the record, it's saying, okay, I don't return this record because this expression is always false. Okay, so what we're doing when we make a select or aware clause is we're creating an expression such that that expression will return true or false or unknown. The unknown part, we can't really touch on super well because we don't have any data that's like null. But what that would look like is, let's say, for example, right? Let's say I have let's say I do unique, and I'm actually just going to select again so I can see the attributes here listed. Let's check out unique clicks again. So we'll say that. So unique clicks, right? And is less than 900. I'm doing this because I want to get less rows just so I can see them all more easily. So when I do this, none of the entries are null for the value of unique clicks. But if they were, then comparing it to the number 900 would be an unknown result. Like having just a missing value, right? Like you can't compare that to the number 900. So that would be an unknown result, which also is false if your whole expression here like evaluates to an unknown result. So if the result is unknown for the whole complete expression, then that's not really a useful result. But when you start to do things like, and I'm just kind of like using this as like just to kind of introduce something to you. It's not really something that you like is super critical, though it is actually really good to know what to do with null data. So here, for example, you can see comparisons with null, for instance, equality in where clauses results in an unknown truth value. So if I say that like if I want to check to see if something is null, like if a value doesn't have a value, if that makes sense, or if an attribute doesn't have a value. Like if I wanted to check for all records where unique clicks is null, that's another operator I can use, which I'll introduce in a second here, or rather I'll say equals null, because that syntax also works. So you see null here is also a keyword in SQL. If I run this, oops, sorry, I need to run the full thing. I get 0 records. It's valid, but I get 0 records because I don't have any null entries. But this would be like an unknown kind of like result. Like it's saying like unique clicks is effectively like not a, it's a null. valued attribute for that record. So this is a little weird. It's a weird concept. It's kind of like a unique concept. It's pretty interesting in SQL. It comes up in a lot of different ways, but I thought I'd introduce it just to kind of like see something pretty, I guess, interesting about SQL in particular. Okay, the rest of the stuff I'm going to try to go through a little bit quickly because I realize we're only 10 minutes away from time, but we've already kind of talked about this stuff actually, so that's good. So predicates use operators. The operators I've been using, you've already seen. Oh, and let me zoom in again. So I used an equal sign here. So this is checking for equality. So I happen to know that there is one record in here with a unique clicks attribute value of 966. If I run this, I'm going to get that one record. What I'm saying here is that I'm saying where unique clicks is equal to, excuse me, the value 966. You already saw me use less than. So I get all records where the unique clicks value is less than 966. Similarly, I can use greater than. Okay, I can also use greater than or equal to 966. We now see the record that includes a unique clicks attribute value of 966. So again, if I remove that, it could still be in here because I'm not really, I didn't order it. We're just eyeballing. We'll talk about ordering at the very end though, so we could confirm whether this was in here or not. But I can assure you that the record that contains a value of 966 is not in here because we're not saying whether it should include something equal to 966. So same thing with less than, right? We don't see the record that contains the value 966, but if we include an equal sign, now we do. Right, so the record is present. Okay. Okay, so we've covered all of those operators. We've covered the equals operator. So there's also the not operator. So I could return every record so that's equal to 966. So there's only one record in particular, but I could say not equal to 966 just as well. Okay, and this will return a record that doesn't have that has a unique clicks value, attribute value, that's not equal to 966. Okay, and this is only returning 64 rows. So remember the row total when we just do a basic select is 65 rows there. So when I run this with the where clause, I'm going to break these clauses up again so you can see which clauses I'm including. So again, no where clause, 65 rows. Okay, where clause 64 rows. So I'm omitting that one record that has a unique clicks attribute value of 966. Okay. What other ones do we have? Okay, these are pretty fascinating operators for the where clause. So these let us do what I guess you'd call it like string manipulation or string comparison or like, yeah, string comparison, a value comparison. But we're doing it like what you might say like literally. So instead of doing like numeric comparisons like we've been doing, what we can start doing is stuff like this, where unique clicks like, okay, we can't say this, or actually we can say that. That's kind of cool. I didn't realize you could do that. This isn't super helpful because it's not like 966. We're just saying that it is 966. But what we could do is something like this. We can say 9 blank blank and then apostrophe like that. So what we're saying here is basically that I want every record where the unique clicks, unique clicks attribute value has a first digit of 9 and then 2 digits of any kind. Okay, so if I run that, I'm only going to get the one record still because there's only one record like that. But maybe if I do it with a 1, because I think there's a couple of records in here in the thousands, I'll probably get much more, and I do. And you'll note that every single one of these, right, starts in the 1000s and has arbitrary digits following that. So basically, remember what this database server is doing, this DB browser application, what it's doing is it's going to every record in the table and attempting to evaluate this expression. And if the result is true, then it's going to return the record. So if unique clicks is like 1 blank blank blank, then return that record. Otherwise, don't return the record. So you'll see, I mean, just from eyeballing that the value 966, that record is not in here. And notice, I want you to keep in mind too, because I think this is good to remember or really establish for yourself when you're learning, like this record is the same every time. Like you're not going to see a different unique reach value or a different impressions value or a different FB ID value. This record is the same every time because I'm not changing any of the data in the database itself. All I'm doing is asking about that data. I'm looking for the data and returning it. So every time I find this record, it's going to have the same exact data. And this is a very important tenet of SQL, like SQL databases, is that they store records which are fundamentally like unique entries in tables. Otherwise we wouldn't be able to do things like access to Twitter account or things like this. Like if the data was changing every time we accessed it, if we couldn't rely on particular pieces of data sort of staying in place, then we couldn't really query on them or ask questions about them. Okay, so I'm going to use an example like this just to show you a few more. So another thing I can do here is say, and then we're going to change the attribute that we're looking at. So I can say something like this as well. I'm going to copy this. So instead of saying like, I can say not like. And notice this FB ID here. So I can say an FB ID that's not like 33 and then blank. So this will exclude any FB IDs that have a prefix of 33. And I mean, it looks like basically all of them are pretty unique. So, it's going to be kind of random which ones we don't get, but it looks like there are 62 rows. So there are 3 rows that do have an ID like this, and we can put the like back and we'll see those 3 rows. So there's these 3 rows here. Okay, so what else can we do? Well, we can say, we can use what's called a wildcard. A wildcard basically says anything after this character, so this character, and this character, anything after that, anything goes. So like return anything that matches that, but you just need to match these first 3 characters. What this is saying, this underscore is saying there can be any character here, but only one more character. So this will return no rows. Like there's nothing in the database with 1 character after the FB, but there are things in the database. In fact, every record in our table here has 4 characters after FB. So we get all 65 rows. But what we could also say is just use this wildcard, this %sign, and then we'll get all of them just the same. So it's basically saying like, I don't care what's after this point. Just get me anything that matches this. As you can see in this case, these all match. So it's not a very helpful filter, and this would be weird to do on like numbers, but we could do it on numbers as well. There's nothing wrong with doing that. So we could say, get me all impressions that start in the 2000s or start with 2, really. They could be 200, the number 2. This will work. So just get me all of them. And I got 9 rows. So there are 9 rows with an impression starting with the number 2. So, okay. So I think that covers all of our filtering interest. I didn't quite get enough time to get to this, and this is really interesting stuff. So if it's okay, I'm just going to go over like a little bit, but if you need to leave, feel free to do so. Like I, of course, understand. But I'll probably talk a little bit about this, spend the next couple of minutes or so talking about this. So select statements have a couple of like other capabilities for really maximizing the way that you return records and view records that I wanted to address. These are going to be all over the place. Some of these things are going to be part of the select clause. Some of these things are their own clauses independently. So I'm going to talk about them kind of uniquely. So the first one being distinct. So distinct is pretty simple. Distinct just means that I want you to get all of the attribute values that I specify distinctly. So what I'm going to say is select distinct FBID from the keyword again. And remember how I said about clauses starting with keywords. I don't know if I'd technically call this a clause, but just because I'm using a keyword, it doesn't mean it's starting a clause, but every clause starts with a keyword. Hopefully that's clear. So I'm going to say select distinct FBID from Facebook info. You'll notice too that I'm adding the semicolon to the end of a lot of these statements. I'm just doing that because that is technically the way you terminate a SQL statement. You don't have to add that, especially in like an interactive environment like this. It's usually totally fine. But if you have a subsequent statement, SQL might get confused and think that you're trying to have two statements like together. But so technically the correct way to terminate a statement is to use the semicolon. Okay, so if I run this, oh, my rows aren't updating. Huh. Oh, it kept running. Whoa. Why did it do that? Okay, now it's, I don't know what happened there. It was just gonna run forever. Yeah, if you ever see that happening, by the way, for debugging purposes, you'll see that the play button kind of like goes out of view for a second. Like it kind of like disappears, or not disappears, but you can't click it. And you'll see that this button becomes active. So notice when this button like lights up, it means I can stop the query. If you ever see that happening for quite a while, you can always interrupt the query and just double check your query to make sure it's what you expect it to be. This one was correct. I don't know why it continued to run for so long, but in this case, you'll see 65 records were returned and only that attribute. You'll notice if I try to add another attribute here, like impressions, it will basically just return the impression for some arbitrary value for this attribute that was distinct. I don't know if that really makes a ton of sense, but basically, if you have duplicates, right? If I have duplicate FBIDs, and maybe this isn't the best example because none of these FBIDs are duplicated. That's why it returned 65 rows. I wonder if any of these are duplicates. I mean, we can find out pretty easily using our distinct query. So if I say distinct impressions, that returns 65 rows. Unique clicks, maybe. That also returns 65 rows. Reach. That did 2. We don't have any distinct, or we do, everything is distinct, basically. So this doesn't really come up in any unique way for us. But if we did have stuff that was like duplicated, then what we would see happen is basically that record wouldn't get returned, but you couldn't really know which record wouldn't get returned. It would just choose one arbitrarily. It would choose an arbitrary distinct record to return. So I hope that makes sense. I think I got a little convoluted there, but basically the point is like you're checking for uniqueness. So you're just trying to find only the unique items. And so if there are duplicates, then it'll just exclude as many duplicates as there are. Okay, aggregates. Aggregates are really useful keywords. Aggregates are basically going to let you do summarizing statistics or like summarizing results functions, results like assessments on your data, like on your results, on your records. So one, for example, might be count. So what I can do in particular with count is I can basically add a where clause. Okay, and I can say where again, like what we're already familiar with. Unique clicks is greater than 5,000, right? So normally we already know what this would do, right? It would return all records where unique clicks, the value for that attribute is 5,000, okay? But if I run this, what it's going to do is it's just going to give me the count. of records where that criteria is met. So it's kind of like what this result, like this execution summary is doing below, really. Yeah, like it's not particularly unique in this case, right? Like if I run this, it's going to say 13 rows returned. But sometimes I might want to do something, pretty unique with that data. And I usually put a star here because it doesn't really matter. I'm getting an aggregate count anyway. Like there's not, it doesn't really matter if all of my records have data in them. It doesn't matter which attribute I count on. So you could just count on all attributes because we're returning the full record. But I could say something like FB ID, but that'll get me the same value. Like it's just saying basically I found 13 FB IDs. And that's because there were only 13 records with unique clicks over 5,000. Okay. You can imagine what sum does. Sum is basically going to sum the attribute values for all of the records that you found in the table using this query. So FBID doesn't make a lot of sense because it's like a unique value, but impressions is just a number. So if I sum this, I mean, I don't know if this is true, but of course I believe SQL is giving me the correct result. So I'm going to trust it here. But basically, if we were to manually go through, right, and we were to take this, right, select star, but we'll only select impressions. Okay, and then we were to take this by clicking up at this top left region. We were to copy this data. If we pasted it into a spreadsheet and we used Excel and we did the sum, we would find the exact same result as we were to do this. So the same exact result should come about. And then the max is another really useful aggregate. These are all called aggregates because effectively what they're trying to do is they're trying to aggregate your results to one single result. So that's the point. It's an aggregate result. The max, if you can guess, but of course I write it out here. So it returns only the maximum value for the selected attribute. So basically, this is the highest value. The highest value for that attribute in this table. So of all the records in the table that have a value for this attribute, this is the highest of them all. So this is really useful for doing certain types of like data analysis. I don't think I'll get time to kind of get to these. So I'm going to pick which one. I mean, you can read the notes, I think, and just try it out. But I want to just show this one really quick because it'll help us verify what we got for here, this max impressions. So this last one is actually a new clause. So now we have basically 4 clauses that we can be working with. So the select clause, the from clause, the where clause, and then what I'm going to do here is just return this to impressions. And remember this number, 9997. So what I'm going to do now is add a new clause, the order by clause. The order by clause. So what this is really useful for is previously, when we've been running our selects, something really useful to note is that although this application is going to return the results that you see here, effectively, my understanding would be basically the same exact order every time that you run the query. That's not guaranteed. Like there's nothing that you're doing in this query to indicate that SQL should return the results in any particular order at all. So it's very possible that the next time I start up this database, I run the same query, I could get a different impressions value here because it's just going to arbitrarily return records that meet my search criteria with this where clause. But it doesn't mean that it's trying to return them in any particular order. That's where the order by statement comes into, or the order by clause comes into play. So I can say order by, and I can say impressions, okay? And when I do this, what it's going to do is it's going to begin to order my results in order of the impressions value. So if I run this, now what I'm going to see is I'll see the list of results in order of impressions values. So 6809 up to 6866, up to 7076, and so on, all the way up to, hopefully you remember this number, 9997. So you'll notice that this is the result that we got for running this max keyword, kind of like aggregate function on, like with our select query. And by default, meaning like if you just run this clause, if you just include this clause like this with this query, you'll get an ascending list. So ascending order. If we want descending order, what we do is we just add a little DESC keyword at the very end of this and click run. And now it's going to show results in descending order. Notice it's not changing the number of records returned or anything like that. We're in a new clause beyond the where. So we're not filtering the data anymore. We're specifically ordering the data. This will not change the type of data, or like the content of the data we return. Okay, so I didn't get to all of these, but definitely read through these. They're pretty interesting. They're pretty unique ways to use select statements. I think that's kind of everything that I wanted to address, though. We definitely got really far, covered select statements. So next week we'll cover, or sorry, not next week, the week after next week, we will talk about using updates, inserts, and deletes. So those are new series of statements that we'll discuss, and we'll kind of introduce similar way that we talked about select statements. And those things are going to let us add data, modify data, and remove data from the table. So we'll be doing like changes to the database. And by the way, when we do that, you can just I think you can save the database. Yeah, like whenever you make changes, it'll basically prompt you to be like, oh, like, do you want to write that? And you just click that. But we didn't make any changes. We've just been viewing data. So this is as far as we got, basically. In fact, we had some pretty complex filters. So this is pretty cool. We started from here with just 2 clauses. We added 2 new clauses by the end, and we added predicate expressions in order to get like more data out of our query. So, or more refined data. So yeah, I think that's it. Thanks for joining, everyone. And yeah, see you next time, I think.
Thank you so much.
Yeah, thank you. This is great.
Awesome. Yeah, awesome. Cool. All right. Yeah, see you next time.
Give me one. Okay, bye everyone. Let me disconnect from here, and you wanna meet like in 15 minutes, 10 minutes?
Yeah, sure. Yeah, why don't you send me an email in 10 minutes?
I will.
Okay.
All right. Sorry,
bye.
my baby is.
No problem. No problem.
Bye.
Okay, bye.
Bye bye.